Bismillah Rahman Rahim. So, the course that I would be teaching you this semester is mechanical vibrations. Uh, this is about my introduction. I'm Dr. Farid Khan, professor in UET Peshawar. I'm working in UET Peshawar since 1997. I did my BSc in mechanical engineering 1997. MSc in Mechanical Engineering Design 2005, and I did my PhD in 2011 in micro electromechanical systems. Uh, Mechanical vibration. Generally, vibration actually exists in nature. It is a physical phenomena. It exists in universe. And after the slides, you would come to know that vibration is all around us. The definition of vibration, the periodic motion or the to and fro motion which repeats itself after an equal interval of time, it's known as vibration. So any object or subject which it moves to and fro, and that motion repeats itself, so we would call it vibration. So the coming slides are about the applications or usage or where we could find out vibration and why we study this course, that is mechanical vibration. So let's go and discuss those slides. Vibration is all around us. It exists in our daily life, it exists in the world, it exists in the universe. Uh, Starting from the beginning, you may have studied this in your metric, the simple pendulum. It comprised of a suspended mass through a string, and if you disturb the system, if you give motion to the pendulum, so this mass would oscillate about this position, which is known as the mean position. This oscillatory motion is repeating itself after an equal interval of time. Such type of motion is known as vibration. It is actually mechanical vibration. Mechanical mechanical means motion. So anything which is moving, it is mechanical. So mechanical vibration, the vibration in the mechanical systems is known as mechanical vibration. So in this course, we would be studying the vibration in the mechanical components. So the course name is mechanical vibration. Here you see another example. This is the guitar which is used to produce acoustics or sounds. So it comprises of a string. The string, both ends are fixed. One end is fixed here and the other is fixed here. The strings are tied. So when you plug the strings, the vibration of the string is producing the acoustics or sound in air. So here you are seeing two vibrations. One is the vibration of the string and the other is the vibration of the sound. Sound is traveling in air, and sound is traveling through the compression and expansion waves. So it is also vibration, but in this course we would be not studying that vibration. We are not studying the acoustic vibration, vibration in air, vibration in water, etc. Here we would be studying the vibration in mechanical components. Here we would be studying the vibration of the string. String is a mechanical component here. We will study that in this course. Another example is when a vehicle is moving on a bumpy road, so the whole vehicle is vibrating. The passenger or the driver sitting inside is actually vibrating. Similarly, in case of earthquake, the whole structure, the civil infrastructure is moving or it is vibrating. Some more examples. The waves in ocean are actually producing vibration. That is also vibration, but we will be not studying the actually the vibration of the waves. we are interested in the vibration of the mechanical system here, which is a boat. So how the boat oscillates in regard or due to the vibration of the waves or motion of the waves. So we would be studying that. So the oscillation of the boat because of the motion of the waves is a mechanical vibration. Some more examples in your daily life you may have noticed, or you may have felt the mechanical vibration. For example, refrigerator. Refrigerator during operation, it is vibrating. If you put your hand on the body of the refrigerator, you would feel the vibration. Although the vibration is not so strong, you would not see the vibration. But when we put our hand, we normally feel the vibration. Similarly, window type air conditioning. In window type air conditioner, if you put your hand, you would feel the vibration. From where that vibration is coming, the culprit is actually the compressor. This is the sealed compressor which is used in the refrigerator and in the window type air conditioner. It is known as sealed compressor or aromatic compressor. Inside the compressor we have piston and cylinder arrangement, which is actually attached to the electrical motor. The electrical motor is the driver machinery which is giving motion to the piston in the cylinder of the compressor. And because of that reciprocating motion, this compressor actually vibrates, and its vibration is a little bit severe, and because of that vibration the whole refrigerator and the window type air conditioner that vibrates, and when you put your hand you would feel the vibration. These are mechanical components, so the vibration which is produced in them, they are known as mechanical vibration. Some more examples. um, Blinder in which you make juice. So if you operate this, you will feel vibration. You will see the vibration. It will be vibrating severely, and that vibration, because of that vibration, is actually the electrical motor, which is here, which is actually rotating these blades. So vibration is there. Similarly, in washing machine, the vibration is severe. You could see even the vibration. If the machine is new, the vibration is uh, less. However, if the machine is old, you would see tremendous amount of vibration. The vibration here is because of two reasons. One reason is that we are putting cloths which are wet, and this is the drum, and this drum is rotating. So there is an uneven mass in the form of the wet cloth which is producing vibration in the system. The other reason is the electrical motor, which is also producing the vibration. Some more examples. Mixers. Mixers, there is electrical motor here which is producing vibration. Blinders, electric motor here which is producing vibration in the machines. These are the blades or rotors of the uh, blinders, which could also produce vibration if there is some unbalance in them. So the vibration is there. So in our houses, house appliances, there is vibration. Similarly, the microwave oven. If we operate the microwave oven, and if you put your hand on the microwave oven, you would feel the vibration. Again, the reason is that there is electrical instruments, for example, transformers. Transformers also produce vibration. Electrical instruments like transformer produce vibration, in which which the voltage is either stepped up or stepped down. Vibration is also there. Similarly, there is electrical motor here which is moving this disc inside the oven. It is also producing vibration. In laptop also vibration is produced, and the culprits here are the air fans. There are air fans there which is actually circulating the air in order to keep the electronics of the laptop cool down, and similarly also the culprit is the CD drive. If you put the CD in the CD drive and you are using that CD, then you would feel a little bit vibration in your laptop, and that vibration is because of this small high-speed motor which is rotating with a very high speed, and it would cause that vibration. Vehicles vehicles also vibrates, and the vibration in vehicles is because of two reasons. One reason is the engine, which is actually in most of the vehicle we have reciprocating engines, which comprise of a piston cylinder arrangement, and the reciprocating motion is then converted into rotary motion. So there are a number of mechanical components. So the engine is vibrating. Although the engine is on the isolation pads, they are on the isolation pads or dampers, but still the engine is vibrating. And when the vehicle is new, the vibration of the engine is less. However, with the passage of time, when wear and tear takes place, the engine gets old, the vibration becomes more severe, and we could see the engine vibration. So one of the reason is the engine vibration, and that engine vibration is actually transmitted. It transmits to the body of the vehicle and into the passenger cabin. So if the engine is started and we are sitting in the vehicle, still we would feel the vibration of the engine inside the passenger cabin. Similarly, the other reason for the vibration in the passenger cabin or inside the vehicle is the road, the bumpy road. So when the vehicles are moving on the road, so the roads are not even. If they are, if we see them very smooth, still they are not even. So we could feel the vibration inside the vehicle. So one of the reason is because of engine, and the other is the roads. As the vehicle is moving on the roads, the bumpiness of the roads is transmitted to the vehicle tires, to the suspension system, into the vehicle body, and into the passenger cabin. Normally in the vehicle we are trying that we want to reduce the vibration which is transmitted from the ground, from the road into the passenger cabin, and for that into the body of the vehicle, and for that we have the suspension system. This is the suspension system of the vehicle. Uh, this is the front suspension system, and this is the back suspension system in the heavy loaded vehicles. So the suspension system comprised of a this shock absorber, which is actually the damper, which is damping the vibration, and this spring. This is the spring. Here you could see this is a coil spring. So it the front suspension system, or in most of the small vehicle, we have the suspension system like this. That is, it is comprised of a coil spring and the shock absorber, which is a damper. It comprised of a piston and cylinder arrangement, and in the cylinder we have oil. Here again, you could see the shock absorber, the damper, and the coil spring. This is the suspension system, and the main objective of this suspension system is to damp down the vibration coming from the ground or roads, and we want that those vibrations must not reach the passenger cabin. Similarly, here this is the rear suspension system for a heavy loaded vehicles. Um, these are springs and they are known as leaf springs, and the main objective is again to damp down the vibration coming from the road. Normally, in all machines in industry, we use machines, and in all machines there is vibration. When the machine is new, the vibration, the amplitude of vibration is less. However, with the passage of time, as wear and tear takes place in the machine, or if there is some mechanical fault in the machine, then the vibration would be severe. Uh, there could be a number of reasons. We would discuss those reasons later on, that what are the causes which actually produce vibration in the mechanical systems or machines inside the industry. So electrical motor. So when the electrical motor actually converts the electrical energy into the mechanical energy, the rotor is rotating or the shaft is rotating, the motor vibrates. The vibration is less when it is new. With the passage of time, the vibration gets severe. Or there could be other reasons which we would discuss later on. Fan. Fan. When the fan is rotating, the fan is a driven machinery, and we have to rotate these blades with the help of electrical motor. And as the electrical motor was vibrating, fan would be vibrating, and also if there is some imbalance in the blades of the fan, it would vibrate. So vibration is there. Pumps. Pumps also vibrates. Pumps are used to transport liquids. So normally it is a driven machine. It is assembled with the electrical motor, which is actually driving the pump. So two machineries are there, and you could even feel the vibration if you put your hand. Pulley and belt arrangement, the vibration is there. In civil infrastructure, vibration also occurs. Here you see, I have put a picture, and this is a steel and concrete structure. This bridge is made of steel. However, you see that it is severely vibrating. And this bridge is Takahama Bridge. It was built in, I think, 1940s, and just after its inauguration, within few days, it start severe vibration, severe oscillation, and after a few days, it collapsed. So you could see the vibration, and here you could see the failure or collapse of the bridge because of the vibration. And it was found out that the main cause of this vibration is high-speed winds. The designers, when they were designing that bridge in that time, they ignored the effects of the high-speed wind. They ignore that. They just assume that the high-speed winds would not produce any vibration in the bridge. It would not cause any damage to the bridge, so they ignore it. But when they build the bridge, and within few days, when high-speed wind started blowing, so it produces severe vibration, and this bridge was vibrating just like the jelly, and within few days it um, uh, within few days it's collapsed. So after that, then the engineers started thinking that we have to also consider the wind in the designing of the civil infrastructure. The video is available on the YouTube. I will show you the video of this bridge later on in the lecture. The main objective of showing you this video is that vibration is normally could be devastating. It could damage your millions and trillions of dollars infrastructure within seconds. So you have to consider the vibration in machines, in systems, in civil infrastructure very seriously. Some more examples. This is the mechanical chisels, which are used to break the rocks or road. So you may have seen those on those roads when the BRT were actually they were making BRT, so they were using these machines. So here we have a chisel which is vibrating with a frequency, and they are using it to break the rocks or concrete, etc. Some more examples: earthquake. Earthquake. In earthquake, actually the ground is vibrating. The ground is vibrating, and that vibration is transmitted in the civil infrastructure. And if the civil infrastructure is not properly designed for the earthquake at that locality, so normally the results are very devastating, and it is the loss to the infrastructure and the loss to the human lives. So here you see two guys, and they are doing something on the machine. Actually, they are monitoring the machine. You could see that these are the electrical motors. So, or they may be electrical generators. In industry, we continuously monitor the machines, especially the critical machines. Critical machines are those machines which are very, very expensive and for which we don't have a standby in the industry. So we continuously monitor the vibration of the machine. Vibration is one of the indicators which tells you about the health of the machine. As I told you, when the machine is new, its vibration will be less. But as with the passage of time, as wear and tear occurs in the machine, so the amplitude of vibration would increase with the passage of time. So normally, and also if some damage occurs in the machine, for example, if there is some fault in the bearing, then we would see more vibration. If there is some fault in the shaft or attached pulley, then we would see severe vibration in the machine. So normally vibration tells us about the health of the machine. So normally in industry we use vibration to identify or to know about the condition or health of machine. So we continuously or we continuously monitor the vibration. If the vibration levels are within the limits, then we say the machine is okay to use. But whenever the vibration levels become exceeded, then the authorized limits, and immediately we stop the machine and we say that there is some fault. And even the levels of vibration, the nature of the vibration actually tells us about fault, that from what type of fault is there. Either there is uh, rotor fault, or where there is bearing fault, or some other fault. So even from the spectrum of the vibration, we could easily identify the type of fault. So mechanical vibration is very, very important subject. Most of the time we are using this subject for the condition monitoring, for the health monitoring or condition monitoring or predictive maintenance, also known as predictive maintenance of the machine inside the industry. And so very, very important subject. We have to learn this. Its practical utility is very much inside the industry in our daily life. So actually, whenever you visit the industry, you would see in the industry there would be continuously monitoring the machines, because if the machines, because of any fault, if catastrophic failure occur to the machine, then the production would stop. and actually the industry is not ready for that. So normally they continuously monitor the machine and they schedule its maintenance depending upon how the wealth of the health of the machine is deteriorating. So by that they actually do the scheduled shutdown rather than emergency shutdown. They could save thousands of their dollars and rupees. Some more examples of vibration. This is the passenger aircraft, and in passenger aircraft, the reason of vibration, there are a number of reasons for vibration. The main two are when the aircraft is moving in the flying in the air. In the air, there are low pressure pockets which produce vibration in the aircraft. Similarly, high-speed winds could also produce vibration in the aircraft. Also, we could see these are the engines, jet propulsion engines, which are attached to the wings. And these jet engines, there are compressor turbines, which are rotating with very high speeds. They are producing vibration. This is the fighter aircraft. Fighter aircraft, there is also vibration. The engine is actually inside the aircraft. This is the nozzle of the aircraft through which high temperature and pressure gases are expelled out, and it is giving thrust to the aircraft. Again, the high pressure, the air pockets um, produce vibration, high speed winds, and also the engine which is inside the aircraft, it would produce vibration. This is the aircraft carrier. You could see the aircrafts on its deck. Normally the vibration, there could be a number of reasons for the vibration of this aircraft carrier. One of the reason is the waves which are moving in the ocean. The second reason could be the wind which is blowing over the ship, and the third reason would be the engine. The fourth reason would be when these aircrafts are actually taking off or doing landing on the ship, so there would be vibration on the ship. Helicopter, winds produce vibration. Similarly, you could see the rotor blades of the helicopter, so the vibration is there. This is the space shuttle. Space shuttle, and this is the rocket. Um, and you could see also the booster rockets here. These are the booster rockets, and these booster rockets actually initially they are used to take the space shuttle into the upper atmosphere, and afterward they are disconnected from the space shuttle, and later on the jet engines of the space shuttle are actually it started to operate, and you could see the nozzles, and through these nozzles we are actually um, taking out the high temperature, high pressure exhaust gases, and which is giving thrust to the space shuttle. So the rocket, when the high pressure, high temperature gases are exhausted through the nozzle, so they produce severe vibration. So the vibration is here. Similarly, here in this space shuttle, when the high pressure and high temperature gases are exhausted uh, through the nozzle, then the vibration will be produced. Missiles. Missile is a rocket propulsion power plant. So here we have fuel, oxygen or fuel, and in the combustion chamber. In the combustion chamber, we burn that fuel in the presence of oxygen, and high pressure, high temperature gases are produced, and those high pressure, high temperature gases are then expanded through the nozzle. And as they are expanded through the nozzle and they leave the nozzle in the downward direction, they give the upward thrust to the missile. However, they produce severe vibration, and we have to control that vibration on the missile. Otherwise there would be no accuracy of the missiles. So here you see that uh, this is the missile which Pakistan has produced. So I have put that picture. Also, space rovers, the space rovers which we have sent to the Mars, the vibration is there. So, for example, the cameras and the instruments all are there, but when they are sending the pictures or live images or movie clips, so you would see we see the vibration in those, and those vibration is because of the terrain. Because of the terrain, you could see that the bumpy ground there, so that is the cause of the vibration. Moreover, there would be motors which would be producing the vibration in these space rovers. So we have seen that the vibration is all the mechanical vibration occurs in all mechanical systems, and they are all around us, and normally we come across those vibrations, and those vibrations are actually in our homes, in home appliances, and whenever we go in our daily life we could feel these vibrations. And also the applications or these vibrations exist from house appliances to the space rovers which we send to the Mars.